Slope-Intercept Form. Vocabulary. Slope-intercept form. An equation for a linear function in the form y equals mx plus b, where m is the slope and b is the y-intercept. Y-intercept, the ordered pair xy where a graph crosses the y-axis. This formula is very important because you will use it for a lot of algebra equations and stuff, or base it off of that. So y and x is the ordered pair from your graph. The letter m is the slope of the line, the angle, the direction of the line. And b is where it crosses over the y-axis. So that's how you get your letters. Your m and your b are very important. Determine the slope and the y-intercept of each linear equation. Number 1, y equals negative 1/2 x. If you notice, in red, negative 1/2 is connected to the x. That is the slope of your line. But you also have the equation of y equals mx plus b. If you notice, there is not the plus b at the end. So that's where you're going to assume that the y-intercept is going to be 0. So the slope is negative 1/2 and the y-intercept is 0. Let's look at problem number 2. Y equals 4x minus 5. Remember, the slope is connected to the x, so in this case we have a positive slope of 4, or 4 over 1, and then our y-intercept is negative 5. Determine the slope and the y-intercept of each linear equation. We're going to do problems A and B together, and then I would like for you to go ahead and do C and D in your journal and come back and check it. So letter A, let's determine our slope. So we're going to look for our slope and our y-intercept. Remember, our slope is connected to our x value. The number that's connected to the x is 3. Or 3 over 1. Our y-intercept is the number by itself. In this case, it's positive 10. You pull the sign that's with it. Letter B. Our slope is negative 2/3. That's what's connected to our x. And our y-intercept is 0, because if you notice, there's nothing added on to the negative 2/3 x. So our y-intercept is 0. Go ahead and complete C and D, pause the video, and come back and see how you did. Okay, letter C. We have y equals negative 5x minus 4. Your slope is negative 5, or negative 5 over 1. Your y-intercept is negative 4. You pull the sign that's in front of it. Letter D. Y equals 1/2 x plus 21. Your slope is 1/2, and your y-intercept is a positive 21. 2 leopard geckos were 3 inches long at birth. Gecko A grows at a rate of 1/3 inch per week, and Gecko B grows at a rate of 1/2 inch per week. The total length of Gecko A, y after x weeks, can be represented by y equals 1/3 x plus 3. And the total length of Gecko B, y after x weeks, can be represented by y equals 1/2 x plus 3. A. Graph each equation. Determine the slope of the and y-intercept for each equation. So let's look at Gecko A. Our slope is connected to our x value, so our slope is going to be 1/3. Gecko B, again, our slope is connected to our x value, so our slope is going to be 1/2. Let's look at our y-intercept. Remember, our y-intercept is our number if we have y equals, and in this case, both of them are 3. Step 2, graph the y-intercept for both equations. So, our y-intercept in this case is going to be 0, 3. It has to be where the y-axis is and it starts. So we're going to go ahead and place a point at 0, 3. And that's for both of them, so we don't have to do 2. Step 3, write the slope as rise over run. Locate a second point for each line. So starting off with letter A, I'm going to use black ink for A and red for B. We're going to do our rise over run. So you're going to go and you're going to rise up. So I'm going to do dots. Go up 1, and then we're going to go over 3. 1, 2, 3. Place a new dot. We can keep doing this to form a line. Go up 1, then go over 3. 1, 2, 3. Place a dot. One more time. Up 1, over 3. 1, 2, 3. Place a dot. And we can make a line. Let's do gecko B. Using the same idea. Starting at the same point, because they have the same y-intercept, we're going to go up 1 over 2 this time. So you can kind of see how the line changes. So up 1 over 2. 1, 2, so my point. Up 1 over 2. 1, 2, my new point. Up 1 over 2. 1, 2, make a new point. One more time. Up 1 over 2. 1, 2, make a new point. I'm going to connect those and make a line. Remember, gecko B is red. We have gone through step 4, draw a line connecting the 2 points to the equation so you can kind of see how they're different. Alright, so let's talk about how things turned out. Letter B. Compare the growth rate for each gecko. The slope represents the growth in inches per week, which is the rate of change. The growth of gecko A is 1/3 inch per week, and while B is 1/2 inch per week. So growth of gecko B grows faster than A, which you can see by the lines, has a steeper slope. Complete this problem as just like what we did prior, and then come back and we'll explain how to do it. So pause the video. Jack has written 30 pages of his novel. He plans to write 12 pages per week until he has completed his novel. Lauren has written 30 pages of her novel. She plans to write 15 pages per week until she has completed her novel. The total number of pages Jack has written, Y, can be represented by Y equals 12x plus 30, where x is the number of weeks. The total number of pages Lauren has written is Y can be represented by Y equals 15x plus 30, where x is the number of weeks. So first thing is A, graph the equation. Jack is Y equals 12x plus 30. Jack's slope is 12, or we're going to represent it as 12 over 1. His y-intercept is 30. First start off with your y-intercept. So it crosses over the y-intercept at 30. So we're going to go ahead and plot his point. Then it tells me that the slope is 12 over 1. So I need to rise up 12 and run over 1. So going up 12, which is a little bit above the 40, and then going over to 1 whole, which he'll fall right above here. If I completed that again, I'd rise up a little bit above the 50 and go over by the 2. I'm going to go ahead and connect my points for Jack. Now Lauren, her equation is y equals 15x plus 30. So I'm going to go ahead and do our slope. Our slope is going to be 15 or 15 over 1. We need that 1 in order to do our rise over our run. Our y-intercept is our 30. Remember, your slope is always connected to your x value. So we start at the same point that Jack did. So I'm going to plot blue over the black so we can see. But this time we're rising up 15 and going over 1. So we're going from 30 to about 45. So 45 to 60. Go ahead and go up. I'm going to go ahead and do one more, so 75 to 3. And you can see that there's a little bit of a change in slope between Jack and Lauren. You can see that Lauren has a steeper slope so that she has written more pages than Jack has written, even though they started at the same point.